I hope you've noticed that question 1, 2, and 3 have been basically the same. We've been doing the same thing every single time with these composition of functions. First, we want to find an explicit equation. So for A, I want to find an explicit equation. I can color code f of x is the square root of x in my head. I'm like, I know what that graph looks like. It looks like this. G of x is a parabola moved down 4. In my head, I know what that graph looks like. And so now I want to find an explicit equation. First of all, I have f of x right here. For the explicit equation, f of x was the square root of x. Then g of x says whatever you put in gets squared. It gets squared. So what happens when you square a square root? See that would just become x, and then you minus 4. So this is our explicit equation. Oh, and this brings back a little bit of bad memories from semester 1, because this question was on the exam in semester 1. And part A said, get the explicit equation. And part B said graph. And so many students got the graph wrong. I'm going to graph it for you, and you're going to tell me why it's wrong. X minus 4, like it's a line. How hard can it be to graph a line? You just get your y-intercept. Here, I'll graph it in purple. Slope of 1, 1, 2, 3, 4. There's my x-intercept, would be exactly the same. There's my graph. What did I do wrong? Oh, so this, it's going down, I got arrowheads. Well, 4 to the left of, 4 to the right, actually. If you were using transformations before to the right, it does match up, but I would just use y equals mx plus b.
Would there be like non-permissible values?
There's non-permissible values. Okay. Is there any non-permissible values here? No, but what's the domain? There is right here. I'll highlight it. Oh, that's my creative pen. There it is. We have a restriction there. No negatives, right? You can't square root a negative. So machine 1 has a square root. So the domain has to be that x is bigger than or equal to 0. And then when you went to graph it, you were not allowed to graph this part. Three out of my 30 students got that right. The rest forgot. They just got the line. They got so excited. I know how to graph a line. And they graphed the whole line.
So was it, they lost 1 point, or was it?
They lost 1 full point for that. So we have to be careful with composite functions. Sometimes, some teachers say always write the domain with composite functions right after the function to remind yourself where were the restrictions. And you have to check machine 1 and machine 2, because what's happening is in this situation, first, things went into F, and then they went into G, like this. Can you see there's no restrictions on G? G will eat anything. Throw garbage in there, no problem, right? But F is fussier. F is like, no, negative stuff makes me feel sick. I'm not going to eat any negative numbers. Only positive numbers for me. Very fussy F. So then as a result, since it has to go into F first and then into G, even though the explicit equation is like, it's fine. It's just x minus 4. But there was an initial restriction on f, so that's why we can only have x bigger than or equal to 0. Yes?
Wouldn't you also ask the following, such as what would be the common x in the negatives?
The y values can be negative. Because why? If I plug in 0, f is like, it's not a negative number, I'm fine, it munches it up, it spits out a 0. Ooh, this eating analogy is kind of disgusting, because if you eat it, you don't spit it out, it probably don't. Okay, out came a 0. That 0 goes into g, 0 squared, out would come a -4. Negative numbers are okay to come out of the end. It's just that the x values had to be positive, not the y values. So when you're talking about that -4 right here on the purple graph, the x value is fine, the y value, -4 is fine. Okay, part B. Part B has f of g of x. So now, it goes into g first, and then goes into f afterwards. So it gets squared -4 first, and then it gets square rooted second. So this will be y equals, keep it y equals because I want an equation, x squared -4, and then f of x is whatever you put in, you square root. So we get the square root. Did I write it down right? Yep, those were the original graphs. The square root of x squared -4. Okay? Right? This one, g, anything can go into g. But then when we go into f, we have problems. We look at our work. Here, domain is fine. Everything can go in. But now, we have a problem with our domain. Because the inside, the x squared -4, has to be bigger than or equal to 0. And again, this is the review that we did at the beginning of class. You solve it like it was an equal sign, and you get plus or -2. Make your number line with -2 and 2. Oh, it can equal it. Take your time. Should have been a coloring teacher. No, just color, specialty, not just art. Art, you have to do other stuff. No, just coloring.
The different techniques of coloring.
Middle school, when I was in middle school, we colored maps. Did you ever color maps in middle school? So much fun. It's like they do it everywhere, right? I don't know. It's like
Yeah, not yet.
makes so much fun to color map. Did you do the technique where you made the outline darker and then shaded the inside? You guys have good coloring teachers. Okay. Anyway, there we go. -2 to 2. We're going to plug in 0. Is -4 greater than or equal to 0? This section would be false. Plug in -3. This is true. Plug in +3. That's true. So our domain is x is less than or equal to -2, or x is greater than or equal to +2. You could write this in interval notation as well. It would be a square bracket because it's included. And you can circle question 10 as well.